Let's look at two basic problems. We're trying to solve the inequality absolute value of x plus 5 is less than 7. Solve it like any regular inequality. However, remember that this has an absolute value symbol around it. So first solve for the term containing the x with the absolute value. So we subtract the 5. It becomes a 0. So absolute value of x is less than 2. And by the rule, we have two rules here. If absolute value of x is less than 2, then x lies between -2, the smaller one on the left, that's the lower limit, and the upper limit is 2. So the interval is all real numbers between, but not including -1 and 2. So if we had to graph this, it would look like 0 in the middle, -2, +2, and then everything in between, not including the endpoints. Put a hole, and in the interval notation it would be -2, 2. Let's look at the next problem. Here again, we solve for absolute value of x. We subtract 5 on both sides. So x is greater than or equal to 2. Now look at rule number 2 here. If absolute value of x is greater than or equal to 2, then x is less than -2, in this case less than or equal to -2, or x would have to be greater than or equal to 2. So let's graph this. This is -2 and this is +2. Include the 2 because it's less than or equal to -2. Include the -2 and include the 2 here. X would be greater than, which means everything to the right. So in the interval notation, it would be -infinity to -2 including 2. So that's a square bracket, or which is unite with the interval everything greater than or equal to 2. It's anything including 2 or greater than 2. So here we have absolute value of 2x plus 6 is strictly less than 2. So we're going to use the first rule, rule number 1, since we have the less than symbol. And we're going to write this as the quantity within the absolute value, that is 2x plus 6, lies between, and notice the direction of the inequalities. Both go in the same direction. -2 on the left, +2 on the right. Now all we have to do is solve for x just like any other inequality. But follow the rules. The direction of the inequality does not change. We're trying to solve for x, which means we get 2x by itself first. We subtract 6 throughout because we want to get rid of the 6 in the middle. We want to get x by itself in the middle. So -2 minus 6 is -8, less than 2x, less than -4. So adding a constant on both sides of an inequality does not change the direction of the inequality. Next, we want to get x by itself. That's the goal. So 2 is multiplied to x, so, and 2 is a positive number. When you divide throughout by 2, it's a positive number, so that does not change the direction of the inequality. So -8 over +2 is -4, is less than 2 divided by 2 is 1, 1 times x is less than -4 plus 2 is -2. And that's the solution. It can be presented or graphed on the number line. -4, -2. Let's call that a 0. So -4 is to the left of -2. We do not include the endpoints because it's a strict inequality. That's a strict inequality. So we have a hole at the endpoints, and everything in between counts. Writing it in the interval notation, -4, -2. Now let's solve this one. Remember, this is a greater than. If it remains a greater than, we'll be using rule number 2, which is written above, but let's do this. We have 3y plus 1 is less than the negative of 5. This is rule number 2. Or 3y plus 1 is greater than 5. Now we have two inequalities. We solve it just like usual. We subtract 1 on both sides. Remember, we're trying to get y by itself. So 3y, cancel these two, is less than -6. Dividing both sides by a positive number, in this case a 3, because 3 is multiplied to y, we're going to divide both sides by 3. Since 3 is a positive number, the direction of the inequality remains the same. So we have y less than -2. 3 goes 2 times into 6, -2 times into now we solve the right side, subtract 1. Remember, we are trying to solve for y, getting y by itself. So now we have 3y because we got rid of the 1. By adding, or rather subtracting 1 on both sides, it does not change the direction of the inequality. If you add a positive number, subtract a number, divide or multiply by a positive number, the direction of the inequality does not change. Now we have to get rid of the 3. 3 is a positive number. I divide by 3. The direction of the inequality doesn't change. It's still greater than 4 over +3. Cancel the 3's. Y is greater than 4/3. Let's graph this solution. So now we've solved the inequality. We know that y has to be greater than 4/3. Let's say 0 is in here. Let's say 4/3 is here. And -2 about here. Now let's graph it. It's a strict inequality. Put holes. This y is greater than. It includes everything to the right of 4/3. Also includes, the solution includes everything to the left of -2. So if you want to write it as a inequality, or rather as an interval, it would be -∞ to -2 union 4/3, +∞, everything to the right. So 4/3 is the lower limit, everything to the right. -2 is the upper limit, everything to the left of it. So this is greater than or equal to 7. Notice this is the rule that we're going to use. -3x plus 1 is less than or equal to -7, or -3x plus 1 is greater than or equal to 7. Now we solve for x just like before. Subtract 1 on both sides. The direction of the inequality doesn't change. That's a 0. So -3x plus 0 is a -3x. The direction doesn't change because we are subtracting a number. -7 minus 1 is equal to -8. So we subtracted 1 on both sides. Now we have to get rid of the -3. which means we're going to divide both sides by a negative number. Now that's important. If you have to divide or multiply by a negative number, then always remember that the direction of the inequality is now going to change. What was the direction? It was less than or equal to. Now that we've multiplied both sides by a negative number, that's what makes the difference. Now the direction of the inequality goes in the opposite direction. So now we have everything else remains the same except the direction, switching of the direction of the inequality from less than or equal to greater than or equal to. These two cancel each other out and you get 8/3. So x is greater than 8/3, or solve the right side, right equation on the right, subtract 1, so negative 3x is greater than or equal to 6. 7 minus 1 is 6. Now divide both sides by negative 3. That's what you're dividing by. It's a negative number. So what happens to the inequality? It switches in the opposite direction. So we divide both sides by negative 3 because we want to get rid of the negative 3. So now we have, and remember to switch the sign. This is extremely important. Multiplying or dividing both sides by a negative number switches the inequality. So we have x less than or equal to negative 2. So if we had to write this as an interval, it would be x less than or equal to negative 2 would be negative infinity comma negative 2. Anything to the left of negative 2 combined with union anything to the right of 8/3. Everything to the right of 8/3. So if you had to graph this, this would look like, that's negative 2 and everything to the left, and that's, let's say that's 8/3, everything to the right of it, and not including, remember that we're not including, so put holes here.